Hello, my name is Michael Kotyakov. I'm one of the founders of Lectures Without Borders. And today I want to give a lecture on infinity. This is a lecture which is suitable for high school students, normally starting from grade 7 or 8. But even if you are younger, you are very welcome to listen to it. So today we will discuss first a short story which was created by a Soviet mathematician, Naum Vilenkin. There is a small book which I liked very much when I was small. And in this book he tries to imitate Stanislav Lem. You probably know Stanislav Lem was one of the biggest science fiction writers in the 20th century. He was a Polish writer and he created a very famous novel Solaris, but also this one, the Futurological Congress, and the Star Diaries of Ion Tichy. And Vilenkin, when he discusses his story of infinity, he imitates the stories of Ion Tichy. So what happens? We have a hotel somewhere in the universe, and this is an infinite hotel, which means there are infinite number of rooms. So there is room 1, room 2, room 3, and so on. But there is no end. So it goes further to infinity. Oh, it's a nice hotel, but at some point it's full. So though it's infinite, it's completely full. And then I come to this hotel. What can I do? Where can I live? The hotel manager is very smart. He knows a lot of methods to deal with it. So what he says is, it's no problem. We can find a room for you. So the person in room 1 moves to room 2. The person in room 2 moves to room 3. The person from room 3 moves to room 4, and so forth. And then I can come and live in room 1. So it's quite easy. Of course, it's possible only in an infinite hotel, because otherwise the last person would have no room. But there is no last person. Everyone can move to the next number. So it didn't disturb me that at some point I had to move to room 1 million. What happened? There were 999,999 new guests who wanted to come in. And of course, this was an easy solution. So it was just, I had to move to the room million, then the second person to the room 1,000,001, and so on. And so all of them could find some place. What happened next? At some point, I look out a window and I see there is a bus and a large queue of new guests. In fact, it was an infinite queue. How can we solve this problem? Can we find place in an infinite hotel for infinite number of people when it is full? Well, the solution is again quite easy. The person from room 1 goes to room 2. We have heard last time it only can make one room free. But what we do next? The person from room 2 moves to room 4. The person from room 3 moves to room 6, and so on. A person from room number n moves to a room 2 times n. And then there are infinite many spare rooms. So we have room 1, room 3, room 5, room 7, room 9, and so on. And so infinitely many people can move to those rooms. Next problem. Next problem appeared when the first Congress was ready. And so all the guests from the rooms 2, 4, 6, 8, and so on, they actually moved away. Well, okay, we have spare rooms, this is good. But the hotel manager was unhappy. because he said the finance plan doesn't work out. We have half of the hotel is empty. So I don't understand what is the finance plan for an infinite hotel, because you still have infinitely many guests paying. But okay. So what can we do? Again, the solution is quite easy. The person from room 3 can move to room 2. The person from room 5 moves to room 3. The person from room 7 moves to room 4. The person from room 9 to room 5. So we put them all denser together, and again the hotel is full. So you see there are many tricks we can solve when we have an infinite hotel. And the last trick would be what happens if infinitely many buses with infinitely many guests come to this hotel. So now we have two infinities. In every bus, actually, there are as many guests as the hotel has rooms. But we have not only one bus, we have infinitely many buses. There came one manager who had some mathematical background, and he said, okay, what we do is we put all the people from the first bus to the rooms 2, 4, 8, 16, 32. You probably guess these are all powers of 2. We start with 2 to the power of 1, and then we have 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, and so on. Okay, with the second bus, we take powers of 3. We take 3, 9, 27, 81, and so on. So we have 3 to the power of 2, 3 to the power of 3, 3 to the power of 4, and so on. We cannot take 4 as the next number, because if we take 4, we already have someone living in this room from the first bus. But we can take 5. We take 5, 25, 125, 625, which are again powers of 5. 5 to the power of 2, 5 to the power of 3, 5 to the power of 4, and so forth. 6 we could take, but I would prefer to work only with prime numbers. So we can take the number 7 and the power of 7. 49, now it's getting more difficult. What is 7 to the power of 3? 280 and 63, which is 343, and so forth. So these are again 7 to the power of 2, 7 to the power of 3, and so on. Why are prime numbers so good? Well, we are sure that this way we only use different rooms. Because we know for every prime number and for every power, if we take another prime number, let's say P1 and P2, and another power, they are never the same. They're never equal. Well, it's quite easy, because here you only have the first prime number, and here you have only the second prime number. So you're sure it will never be the same, which is a good method. The director was smart enough, and he said we can make it even easier. Instead of doing this, we could just take two numbers, 2 and 3. And let's say we put a person from bus number n. So we have bus n, and we have person with the number m. And we put this person to the room with the number 2 to the power of n times 3 to the power of m. Again, we are sure that since 2 and 3 are different prime numbers, these will all be different numbers. Because, let's take an example. I take 2 to the power of 4 times 3 to the power of 2, which is 16 times 9. If I take something like 2 to the power of 2 and 3 to the power of 4, I have 4 times 81. This is clear, this is not the same. So this method would also work. Still, there is one problem. You know that our director doesn't want to have 3 rooms, because then the finance plan doesn't work. But this way we would have many free rooms. For example, in the first method, room number 6, or room number 12, or room number 10 would be free. In this method, even more probably, all the numbers which cannot be represented as a product of 2 to the powers of n times 3 to the power of m would be free. Well, the best solution came from another person. And I write it maybe with another color. What if we make a table? Let's say we write here all the buses. First bus, second bus, third bus, fourth bus, and so on. There are infinitely many. And here we write the persons from the buses. So it's the first person, the second person, the third person, the fourth person, the fifth person, and so on. And here we have the first bus, first person. First bus, second person. First bus, third person. Here, second bus, first person. Second bus, second person. Second bus, third person. Second bus, fourth person. And so on. So you see it is quite easy. The first number is the bus number. The second is the person's number in that bus. And this way we have a two-dimensional table. Which is infinite. So it goes in this direction infinitely and in this direction as well. But somehow we have to put them all into our hotel. What if we start working like this? So this person, the first person from the first bus, goes to the room number 1. Then we go that way. So the second person from bus number 1 goes to room number 2. Second person from the second bus to room number 3. And the first person from the second bus to room number 4. And then we continue. Room number 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It is clear that we can continue like this infinitely far away. So every room will be filled and every person will find its place. If you are interested, you can even find a formula for that. So let's say you have bus number n, person number m. Can you compute the room where this person should live? It's an easy exercise. So thank you very much. We now heard about the infinity. You will know that there are many different infinities. All the infinities we discussed are called countable, because you can count. You can count all the rooms in the hotel. You can count all the buses. You can count all the persons in a bus. And even, as we now proved, you can easily count all the persons in all the buses, if you go like this. But again, there are different other methods. We'll learn there are different infinities, not only the countable one is the simplest. Goodbye.